Let's take a look at this example, and probably up to this point you realize that in order to be good with factoring, you're supposed to be very good with exponents. Now, we're going to rewrite this term as a to the second power and raised to the third. 2 times 3 is going to give me 6. Minus 64 I can rewrite as 4 to the third power and copy down b to the third. Now let me do everything step by step, and I'm going to write a to the second power to the third minus, use the properties of exponents and rewrite this term as 4b to the third power. As you can see, we got difference of 2 perfect cubes. Okay, now I'm going to use this formula in order to factorize this problem. This is going to be my a, and this is going to be my b. The formula says a cubed minus b cubed is equal, open parenthesis, a minus b first. Okay, so that's why I'm going to have a square, because a represents a square, minus 4b. Close parenthesis, open parenthesis, and I'm going to have a square. I simply copy down a square, and I have to raise to the second power, because remember, this a, okay, this is my a square, has to be raised to the second power, plus a times b. My a is equal a square, and my b is 4b. I have a square times 4b plus b square. My b is 4b to the second power. Now let's perform the operations with exponents and multiplication, and we are going to have a to the second power minus 4b, and I'm going to have a to the fourth power, I have to multiply the exponents, plus 4a square b plus 16b square. This is the solution to my problem. Let's take a look at this example. Anytime you are going to approach problem like this, you're supposed to look at the exponents first, okay? All of them are divisible by 3. Also, 27 I can rewrite as 3 to the third power. Let me copy down everything, whatever I have. X to the third, and I can rewrite this term as y to the second power, and everything is raised to the third, because 2 times 3 gives me 6, plus 8 I can rewrite as 2 to the third power, and z to 15 I can rewrite as z to the fifth and raised to the third power. Now I'm supposed to use the properties of exponents and rewrite this problem as 3x y to the second power, and everything has to be raised to the third power, plus 2z to the fifth, and this term has to be raised to the third power. Take a look. We got the sum of perfect cubes. In order to factorize this expression, we're supposed to use formula for the sum of perfect cubes. This term is going to be my a. This term is going to be my b from this formula. The formula says the sum of the perfect cubes is equal, open parenthesis, a plus b. So I have open parenthesis, a 3xy squared plus b, which is equal 2z to the fifth. Close parenthesis, open parenthesis, a squared minus ab. So this is my a, has to be squared. So I have 3xy squared to the second power minus ab. I have to multiply this by this. 3xy squared times 2z to the fifth plus b squared plus b, which is 2z to the fifth to the second power. Close parenthesis. Next, let's perform the operation with exponents and multiplication. I have 3xy squared plus 2z to the fifth, open parenthesis, 3 to the second power is equal 9, x to the second power is x squared, y to the second, and raised one more time to the second, it's going to be y to the fourth. Negative times positives is going to give me negative. 3 times 2 gives me 6. X y squared times z to the fifth is x y squared z to the fifth. 2 to the second power is equal 4. And z to the fifth raised to the second power is z to the 10th power. Close parenthesis. And this is the solution to my problem.